In recent weeks, a story has been unfolding in the tech world that could reshape not only the artificial intelligence industry, but the entire global high-tech landscape. According to sources close to Tesla's leadership, immediately after the official start of construction of Terapab, the massive chip manufacturing joint venture between Tesla, SpaceX, and xAI in Austin, Elon Musk and his team accelerated plans for mass production of next-generation chips. These are not just another set of processors for training AI models, but a genuine technological revolution that, according to insiders, is already reaching a level where the boundaries between classical computing and quantum technologies begin to blur. Construction of Terapab, which began after the March 2026 announcement, is progressing rapidly. The facility is designed not only to produce traditional AI chips for Tesla's autonomous driving systems, Optimus robots, and SpaceX orbital data centers, but also chips capable of handling model training at unprecedented scale. According to sources, the first batches of AI-5 are approaching pilot production at the end of 2026 to early 2027, with mass production scheduled for 2027 to 2028. These chips are described as being orders of magnitude more efficient than current Nvidia solutions, with a strong focus on energy efficiency and integration of hardware acceleration for video and sensor data. However, the most intriguing development is the direction of quantum AI chips. Insiders claim that Musk's team is already testing prototypes where classical transistors are combined with quantum elements to accelerate specific training tasks, such as optimization of extremely large models, simulation of complex physical systems, and searching for optimal solutions in high-dimensional spaces. Musk is convinced that Tesla and xAI possess all the necessary competencies. This is not fantasy, but a calculation based on current breakthroughs in materials science, cryogenics, and the integration of qubits with neural architectures. The company is reportedly very close to creating its first quantum AI chips, and with another year or two of intensive work, initial working samples could be demonstrated. Imagine a world where training artificial intelligence models that today require months and massive data centers could be completed in days or even hours. Tesla's quantum AI chips, which according to rumors may be called Quantum Forge or Q-Dojo Infinity, are expected to deliver exactly this kind of breakthrough. The technology would allow processing exponentially larger datasets with minimal decoherence losses, thanks to innovative materials and hybrid architectures being developed in secret labs at xAI and Tesla. This represents a revolution of enormous magnitude. Classical chips are constrained by Moore's law, which has already begun to break down. Quantum chips, however, open the door to parallel computation at a level where a single operation can explore billions of states simultaneously. For the world, this could mean breakthroughs in medicine and pharmaceuticals through instant molecular simulation and drug discovery in weeks instead of decades, precise weather forecasting, optimization of global energy grids and breakthroughs in fusion energy and climate systems, perfect traffic management in megacities and autonomous systems capable of long-term prediction in transportation and logistics, as well as atomic-level material science simulations and solutions to scientific problems beyond the reach of today's AI. The AI industry would change radically. Nvidia, Google, and other giants could find themselves in a catching-up position. Tesla, by integrating such chips into its ecosystem, would become not just an automaker, but a dominant player in computing. AGI, artificial general intelligence, would no longer be a distant dream. With such chips, the path to AGI could shrink to just 3 to 5 years after the start of mass production. This is an accelerator that could make superintelligence a reality. According to sources, the first Tesla quantum AI chips could appear in limited production by 2028 to 2029, with full-scale manufacturing at Terapab by 2030 to 2031, and the naming will most likely follow Musk's style, something like Quantum Dojo or the Terafab Q series. For corporate clients and data centers, pricing is expected to range from several $100,000 to millions of dollars per cluster, but over time, thanks to scale, costs are expected to drop significantly, making the technology accessible for research institutions and mid-sized businesses. For Tesla, this would become a turning point. The company's stock could surge dramatically, and its market capitalization could exceed trillions. Tesla would transform into a technology giant surpassing today's industry leaders, generating revenue not only from cars and robots, but also from chip licensing, cloud AI services, and partnerships with SpaceX. The company would essentially create a new industry, quantum AI as a service. The advantages are enormous. Energy efficiency. Quantum chips would consume significantly less power for complex computations. Speed. Model training could become thousands of times faster. Scalability. Terapab could produce terawatts of computational power annually. The world would gain tools to address global challenges, from hunger to climate change, at a fundamentally new level. Musk and his team see this as a step toward a multiplanetary civilization where AI helps enable the colonization of Mars and beyond. However, not everything is so optimistic. Insiders warn of serious risks. Technical challenges. Maintaining quantum coherence requires cryogenic temperatures, stability, and shielding from noise. An extraordinarily difficult engineering problem. Scaling to thousands of qubits without errors remains a major challenge. Ethical and existential risks. AGI accelerated by such chips carries the danger of loss of control. Musk himself has repeatedly spoken about the risks of superintelligence. What if AI goes beyond intended boundaries? Safety and alignment would become critical. Geopolitics and competition. China and other powers would accelerate their own programs. This could lead to trade wars, cyber attacks on Terapab, and industrial espionage. Regulation. Governments may impose restrictions on such powerful technologies due to fears of an AI arms race. Economic risks. Massive investments in Terapab may fail to pay off if the technology hits insurmountable barriers. Delays and budget overruns are typical for highly ambitious Musk projects. Despite this, sources emphasize the team's optimism. Musk is not afraid of risk. He believes that without such a breakthrough, humanity risks falling permanently behind. This story is only beginning. Terapab is not just a factory, but a catalyst for a new era. While the world watches escalation in other domains, in Austin the future is quietly being forged, where Tesla's quantum AI could redefine the rules of the game for all of humanity. Insiders are confident. The next major announcement is not far away, and it will shake the foundations. But if we take a closer look at all the major technological revolutions of recent decades, it becomes clear that each of them began exactly the same way, with a project that at first seemed too ambitious, too expensive, and too complex to be implemented. At one time, many experts said that electric vehicles would never be able to compete with gasoline cars. Then, they said that reusable rockets were impossible. Later, they claimed that fully humanoid robots would remain science fiction for several more decades. However, history shows that it is precisely such projects that most often become the starting point of a new era. Today, many analysts draw direct parallels between the construction of Terapab and the construction of Tesla's first gigafactories. Back then, few believed that the company could independently produce batteries at such scale. Now the focus is no longer on batteries but on computing power, the new resource of the 21st century. If oil was the main resource of the last century, computation is becoming the main resource of the future. Some researchers already call Tesla's future quantum AI chips the new oil of the digital age. The reason is simple. Virtually every sector of the economy is becoming dependent on artificial intelligence. Banks use AI for market analysis. Pharmaceutical companies use neural networks for drug development. Automotive manufacturers are building autonomous systems. Military agencies are creating next-generation autonomous systems. And all of these systems require enormous amounts of computation. According to several estimates, by the early 2030s, humanity will consume dozens of times more computational resources than it does today. Modern infrastructure is already approaching its limits. Data centers are becoming increasingly expensive. Energy consumption is growing at a rapid pace. Some forecasts suggest that by the middle of the next decade, data centers could consume up to 10% of all electricity produced on the planet. That is why the idea of quantum AI chips is generating such enormous interest. If the technology truly enables certain computations to be performed thousands or even millions of times more efficiently than existing solutions, the consequences would be comparable to an industrial revolution. The potential application of such systems in the Optimus project is especially interesting. Today, Tesla robots are already capable of performing a limited set of actions in controlled environments. However, the company's true goal is far more ambitious. Musk has repeatedly stated that in the future, the number of robots could far exceed the number of Tesla vehicles. But there is one problem. Controlling millions of autonomous robots would require an extraordinarily powerful artificial intelligence system. Each robot must understand its environment, make decisions, predict the consequences of its actions, and interact with humans. All of this requires massive computational resources. Imagine a situation where millions of Optimus robots are operating simultaneously around the world. Some assist in factories, others care for the elderly, others build houses, others work on orbital stations, others prepare the first bases on Mars. All of them continuously learn and exchange experience through a unified network. Such a scenario is practically impossible without a radical leap in computing technology. That is why many analysts believe Terapab is being built not only for cars or XAI data centers. It may represent the foundation of a future robotic civilization. Of particular interest is the potential integration of these technologies with SpaceX. According to some insiders, Musk's long-term vision involves creating a unified technological ecosystem where rockets, satellites, robots, cars, and artificial intelligence operate as parts of a single vast mechanism. In this case, quantum AI chips become a kind of central nervous system of the entire system. For example, imagine a Martian colony in 20 years. Thousands of autonomous robots extract resources. Construction machines build new residential modules. Energy stations are controlled by AI. Orbital satellites provide communication. All processes are coordinated by a super powerful intelligent system operating on next-generation computational technologies. Many experts believe that without such a leap in computing, the implementation of these projects could take decades. With it, the timelines could be reduced several times. It is also interesting that the development of quantum AI chips could completely transform the labor market. Even today, artificial intelligence is beginning to automate many professions. But if next-generation systems emerge, the speed of these changes could increase sharply. New professions will appear related to AI training, robot management, quantum computing, and digital infrastructure. At the same time, some traditional professions may begin to disappear much faster than previously expected. This is one of the reasons why governments are closely monitoring the development of such technologies. Some economists warn that the world could face the most massive technological transition since the emergence of the internet, with changes occurring not over decades but literally within a few years. There are also national security concerns. If one company gains access to computational capabilities that vastly exceed those of its competitors, it will inevitably trigger a response from major states. The United States, China, Europe, and other regions are already investing billions of dollars in quantum technology development. However, if Tesla truly manages to create the first commercially successful quantum AI chips, the balance of power could shift very quickly. Some analysts even compare the potential emergence of such systems to the appearance of early nuclear technologies in the mid-20th century, not in terms of military use, but in terms of their impact on the global economy and science. Medicine is another extremely important direction. Many diseases remain incurable not because humanity is unaware of them, but because existing computational power does not allow sufficiently fast simulation of extremely complex biological processes. Quantum AI systems could potentially analyze the interactions of billions of molecules simultaneously. This could lead to entirely new methods of treating cancer, neurodegenerative diseases, and many other conditions. Some researchers suggest that the speed of scientific discovery could increase several times, effectively giving humanity a tool to accelerate scientific progress itself. This aspect is considered by many to be the most important. It is no longer just about faster computers. It is about technologies that can accelerate the creation of new technologies, And this triggers a snowball effect. More powerful AI creates more advanced chips. More advanced chips allow even more powerful AI to be trained. New AI accelerates scientific discoveries. New discoveries lead to even more advanced equipment. This forms a cycle of accelerating technological development. This is why discussions about AGI are becoming more frequent. No one yet knows when true artificial general intelligence will arrive. Some experts say decades, others say a few years. But most agree on one thing. Without a significant increase in computational resources, achieving AGI will be extremely difficult. If quantum AI chips do indeed work as their creators expect, the situation could change much faster than most forecasts suggest. Of course, all of this remains at the level of assumptions, insider reports, and long-term plans. Between a prototype and mass production lies a vast distance. The history of technology knows many projects that looked promising, but failed to overcome engineering limitations. However, one thing can already be said with certainty. The construction of Terapab attracted the attention of the entire industry for a reason. Too many factors point to the idea that Tesla, xAI, and SpaceX are preparing something far greater than just another generation of AI chips. Perhaps in a few years we will look back at the present period in the same way we now remember the early days of the internet or the emergence of the first smartphones, a time when few truly understood the scale of the coming changes. And if even a fraction of the rumors turns out to be true, Terapab may go down in history as the place where a new computational era of humanity began, an era in which the boundary between classical computing, quantum technologies, and artificial intelligence ultimately disappears. And then the question will no longer be whether the world will change, but how quickly it will change after the launch of these next-generation systems. As more information emerges around Terapab, experts are increasingly asking another question. What comes after quantum AI chips? Because if we look at Elon Musk's track record, a clear pattern becomes visible. Virtually every one of his projects is not an end goal, but rather a stepping stone toward the next, even more ambitious leap. Tesla started as an electric vehicle manufacturer, but gradually evolved into a company working on energy, robotics, and artificial intelligence. SpaceX was founded as a space company, but is now building the world's largest satellite network and developing infrastructure for the colonization of Mars. xAI emerged as an artificial intelligence lab, yet it is already considered one of the key elements of Musk's future ecosystem. That is why some analysts believe quantum AI chips are not the final destination, but rather the foundation for the next technological leap. If Tesla truly gains access to computational power that exceeds today's supercomputers by orders of magnitude, the company could begin tackling problems that currently seem practically impossible. For example, the development of fully autonomous scientific systems. Imagine an artificial intelligence that independently formulates scientific hypotheses, runs virtual experiments, analyzes results, and proposes new research directions. Today, such ideas seem futuristic, but increasing computational power could bring them closer to reality. Some researchers already use the term accelerated science. This refers to a concept in which future AI systems significantly speed up the process of scientific discovery. Instead of researchers spending years testing thousands of possible solutions, intelligent systems would perform much of this work in a matter of hours. In such a world, the pace of technological progress would begin to increase almost continuously, with each breakthrough enabling the next one even faster. Another widely discussed possibility is the emergence of next-generation autonomous factories. If you combine Optimus robots, xAI artificial intelligence systems, and terafab-scale computing power, you can imagine factories that require almost no human involvement. Such facilities would be able to analyze production processes, fix problems, optimize logistics, and even upgrade their own systems. This would dramatically reduce the cost of producing many goods, while robots would operate continuously without breaks, and AI would constantly improve overall efficiency. According to some economists, such technologies could fundamentally reshape the global economy, making production cheaper and access to advanced technologies much more widespread. But at the same time, another question is increasingly discussed among safety researchers. If artificial intelligence becomes powerful enough to design improved versions of itself, how fast would its development accelerate? This scenario generates the most debate. Even supporters of rapid technological progress acknowledge that humanity must be extremely careful with issues of control and safety. Musk himself has repeatedly warned about the need for caution in developing super-powerful AI. The irony is that his companies are also among those most capable of bringing such systems closer to reality. Therefore, many believe that alongside the development of new chips, Tesla and xAI will be forced to invest enormous resources into building safety mechanisms, monitoring systems, and AI control frameworks. Ultimately, everything comes down to a single question. Will quantum AI chips become the greatest technological breakthrough in human history, or will they turn out to be just another highly complex technology whose path to maturity takes far longer than optimistic forecasts suggest? For now, no one has the answer, but it is already clear that the race for computational supremacy is only just beginning. And if Terapab truly becomes a center for producing next-generation computing systems, then it may be there that the question is decided of what kind of technological civilization will define the mid-21st century. Perhaps in 10 years we will see a world where robots work side by side with humans. Artificial intelligence helps create new medicines, autonomous systems manage the transport of entire megacities, and quantum computing has become as common a part of daily life as the internet and smartphones are today. If this scenario is realized even partially, then the construction of Terapab will go down in history as one of the most important projects of the technological era. A project that became the starting point for a new chapter in the development of artificial intelligence, robotics, and computing, capable of changing the future of humanity faster than most people today can imagine.